Okay, these are the questions for this week. You have 40 minutes. You have got 40 minutes, so you can start now. Okay, we have a student who wants to measure his weight. The available instruments are a scale A, limited to 400 Newton capacity, and a spring dynamometer B is limited to 80 Newtons, this one. And with the pulley system shown, he pulls on the rope until a scale A reads 268 Newton and the dynamometer B reads 76 Newton. We want to find his true weight W and mass. So this rig actually is a compound pulley system, lots of pulleys sharing the load. The student is part of the system. He pulls on the rope and the force measured by B and stands on the scale, and force measured by A is a scale. The total upward forces acting on him come from the rope tension through the pulleys, which is the TC, okay, and the rope he pulls, which is T1, okay, so we have TC and T1, and the reaction from the scale is F. So we have 3 upward forces, therefore T1 plus TC plus F is equal to W. So each pulley pair balances forces, meaning rope tensions are equal along segments. And after analyzing pulley by pulley, we have TC equal to 4T1. As you see here, TC equal to 4T1. Therefore, instead of TC, we put 4T1. It will be 5T1 plus F equal to 648 Newton. Because 76 Newton is the T1 and 268 Newton is this F. Therefore we have W, and W over G is M. Okay, in the next question, the required torque about the bolt axis is 24 Newton meter, and the wrench length to the pull line is 120 millimeter. I'm talking about this length, not this length, okay? So we change it to meter. 120 millimeter will be 0.12, and across flats of the hex head is 14 millimeter, and distance from the center to a flat is 7 millimeter, and from the center, this small center, to here is 7 millimeter, and the wrench fits loosely, so contact occurs only at the 2 corners, A and B, of the hex inside the smooth jaws. So the wrench is a simple lever, so P times L is equal to 24, then P will be 200. So each jaw, we have 2 jaw here, 1, 2, pushes on a corner. For a regular hexagon, the corner bisector makes alpha equal to 60 degree, so because this is 120, okay, so it will be divided by 2, it will be 60 degree, and perpendicular, this distance actually, this D, so we use tangent ratio, which is 7 millimeter over D is equal to 10 alpha, so we have tangent of 60 degree and we have 7 millimeters, so we find D. So now in the third step we need to find the moment equilibrium. We need to write the moment equilibrium about the bolt axis. Both jaw forces create the required torque, and same lever arm, which is D, so we have FAD plus FBD minus P times 0.12 equal to 0. We are finding the external forces applied to the wrenches, one here, and another one here. So make sure that the force applied to the contact point is towards the object. So we are finding the moments about this point in the middle. I don't know why I didn't show. Okay, I call it O now. Let me do that now. Okay, about point O, which is the middle point. And now force equilibrium on the wrench. So we have minus P downward plus FB and minus FA equal to 0. Two equations here, and we found P. We have two unknowns, FA and FB. We easily find FA and FB. Check your answer. Okay, first we need to draw a halo. I will draw that. So it will cut this part. Oh, it's very thick. Let me use these lines now here from now on. Okay, now it is completely closed. It is an enclosed surface. Okay. Okay, we have a beam mass which is 100 kg. It will be 100 times 9.81 and 50 kg here. So he pulls 150 Newton. I didn't put N here on the rope. Because of the rig, the beam sees two vertical downward rope forces of 150 Newton here because of this rig. So we have T1 at the far left end and T2 at the point 0.75 to the right of it. So we have two supports, a pin at O, okay, right end, and a support at A roller contact, which is again 0.75 left of O. So you need to know the distances from A to use a neat moment balance about A. Okay. So T1, for T1 the distance is 3.25. 0.75 plus 2.5 plus 0.25. So for T2 I'm sorry, from A, moment about A, it is 2.5 plus 0.5 for T1, and for T2 is just 2.5, and for body weight I think it is 1.75, because it should be 2.5 plus 0.75 minus 1.5. Okay, left of A, remember, left of A. And beam's weight W2 is 1.25 of left of A, and reaction at O is 0.75 to the left of A, to the right of A. So horizontal forces, we have just ROX, so it will be 0 because we do not have any other forces. And all applied forces are vertical. So moment about A, 150 times the distance, as I said, 0.25, and again 150 times 2.5 plus 50 times 9.81. Why it is positive? Because it is counterclockwise, and times again 1.75, and plus 100 times G times 1.25 minus ROY I think this also should be positive, and the final answer will be negative. Yeah, it will be downward, the final answer, because if we assume that ROY is upward, so the moment of ROY is counterclockwise about point A, so the answer will be negative. Make sure that you will get this answer. Now this is in Newton, and you need to convert it to kilonewtons. And the last question. Okay, in refrigerator ice cube maker, we have a cube and a small heater, but the small heater is not shown. A motor rotates the ejector arm. This is called ejector arm, okay, to remove the cube. If there are 8 cubes and 8 arms, so we have 8 of these and 8 of these arms, determine the required torque M as a function of theta. Theta might change, okay. The mass of 8 cube is totally 0.25 kg, and the center of mass distance R bar, look at here, we have a R bar here to the center is 0.55 R. So neglect friction, so we don't have any friction here at this contact between this green housing and the cube, and assume that the resultant of the distributed normal force, so we have normal force acting at each point here because these two objects have a contact, so we assume that the resultant force of all of these forces, distributed normal force acting on the cube, passing through point O, passes through point O. It means that the moment, or since the line of action passes through point O, the moment of N is equal to 0, and we have an M here, so we want to find out the moment about point O. We know that it is 0, so we have mg here, mg R bar sine theta, R bar sine theta is equal to here. So is it positive or negative? This is the line of actions from here to here for mg. It is positive, and we have F here applied to the ice. we assume that we wanna show the free body diagram for the ice. So we have mg, n, and f. F is applied by this ejector arm, okay? So F times 36.1. Why 36.1? Because we know that this radius is 36.1. So remember, we have 36.1 and also 37 here. So F times 36.1 is the moment of F, and for mg r bar sine theta, so we know that r bar is equal to 0.55 r is 37, okay? So m is 0.25, g is 9.81, this is r sine theta, and we find f as a function of theta. So now for the arm, this is the arm. Now you need to draw the free body diagram of the arm. F is applied from the ice to the arm. Other way, yep, they are opposite. This F and that F is opposite. And also we have a moment that applied to the arm. So again, 36.1 times F where is that? And F is equal to this value minus m. Why minus m? Because it is clockwise. We are finding the moment about point O. So we have one moment which is applied from the motor, and we have another force that is applied from the cube. So we have two free body diagrams. One for the arm, ejector arm, and one for the ice. So now I will tell you how did I obtain. Let us talk about alpha first. So if this part is 8, and if this diameter as it is set 37 millimeter, alpha will be sine inverse of 8 over 37, okay, 12.49. Then we have a triangle here. We can obtain 36.1. So there is a reason I put this here. There are maybe some issues with this part. This solution is from the Wiley. Check it out and let me know. Thank you very much.